Okay, so for this problem, what we are first going to do is determine what kind of problem we have. So just by looking at this first question right here, we can tell that this is going to be a chapter 9 problem. We see mu, right? We don't see mu1, mu2. So that means it's not a 2-sample hypothesis test. This is just a 1-sample hypothesis test. So it's a chapter 9 problem. Okay, so now that we've established that, we can get started on working on this. The first thing I think you should always do when doing these problems is write everything you have out. So you do this on Excel. I'm just going to do it on here. Okay, so we have the average number of boats owned by people in a lifetime has been 12. That's going to be your mu is 12. Okay. An economist believes that the number is now lower because of recent economic downturns. So this is important, this word right here, lower, we'll come back to that later. So a recent survey of 30 senior citizens, that means your N is 30, that's your sample, indicates that the number of votes owned over the lifetime is 10. So the average number, that's going to be your X bar. So X bar equals 10. And the last key piece of information that we're given is our standard deviation. This is population standard deviation. So population standard deviation is 4.5. Okay, great. Now that we have that, we can figure out what our null and alternative hypothesis is, which is what the first question is asking. Remember how I said in a previous video that typically in these problems, we are given the alternative hypothesis. So right here, this keyword that I underlined, lower, means that our alternative hypothesis is going to be less than, because less than equals lower. So that means our HA is going to be mu is less than 12, right? Because our mu is 12. Okay, what about our H0, which is our null hypothesis? That's going to be the opposite, right? So it's going to be greater than, and our null always has an equals in it, so greater than or equal to 12. Okay, great. The next thing I like to do once we've determined this is to determine what case we have using our cheat sheet. So we said that we have our alternative as less than. So which one does this match with? It matches with this one right here, right? Okay, great. So we're going to be using this, which is also, let's just make a note that this is a left-tailed test, right? This is to the left. So whenever it's less than, that also means it's a left-tailed test. Okay. And just by looking at this really quick, we can see that these set of questions are going to be relating to the p-value approach. All right. And if you remember from the last video that whenever we're doing the p-value approach, the two values that we're comparing to each other to determine if we reject or do not reject our null is the p-value and alpha. So these are the two values that we need. All right. But within the p-value calculation, we also need our test statistic. So our test statistic is a key thing that we need to get. So let's go back to our formula sheet. This is what we're looking at, right? And our test statistic is X bar minus value divided by standard deviation divided by square root of n. Standard deviation divided by square root of n, hopefully you guys remember that as the standard error. So what we're going to do is first calculate the standard error. Then we're going to use that standard error in our test statistic calculation to get our test statistic. So let's do that. So we said we need our standard error. Our standard error is standard deviation divided by square root of n. Now, what is our standard deviation? Standard deviation right here, 4.5. 4.5 divided by square root of n is 30. So there we go. We can plug that in Excel and we would get 0.82158. There's more to that, but we'll just leave it at that. Okay. Now that we have our standard error, we can do our test statistic because it makes it a lot easier when you already have your standard error calculated. So our test statistic formula is x bar minus value divided by, I'm going to do SE for standard error. It looks a bit nicer, neater. Okay, so what's our x bar? X bar right here we said is 10. Our value is what is here. So 12 divided by the standard error. So we're just going to say, let's say 0.82. Okay. When we calculate this in Excel, if you plug in this into Excel, you're going to get negative 2.43. All right. Now that we have our test statistic calculated, we can plug this value into our p-value formula. But what p-value formula do we use? How do we figure out what we're doing? So let's take a look at our cheat sheet. We said that we have a left tail test, right? Because our alternative is less than, right? Let's just take a look right here. Our alternative is less than. So that means it's a left tail test right here. So that means we're going to be using either this formula or this formula. The next key thing that we have to look at is, do we have population standard deviation or sample standard deviation? And it seems like here we have population standard deviation. So we are going to be using this formula right here because we use this for when population standard deviation is known. We use norm. So norm.s.dist test statistic, 1. So we're going to do norm, you're going to do equals norm.s.dist, our test statistic, which we said is negative 2.43, 1. When you plug that into Excel, you are going to get 0.007. Okay. And then whenever we compare the two values, because we're trying to determine if we reject or do not reject our null hypothesis. So we need our alpha and our p-value, right? P-value. This is our p-value, which we just calculated. Value. So our p-value is 0.007. Our alpha is given to us right here. Something that we can just pull from here really quick. 0.10. P-value is less than alpha, or alpha is greater than the p-value. And if we look back at our cheat sheet, we see if alpha is greater than our p-value, we reject. So this means we reject. So now that we have all of this stuff calculated, it's very easy to go through this and to answer all the questions. So our null and alternative, we determined that here, the answer is going to be A. Okay. Let's go to 14. What's our standard error? We calculated our standard error right here, 0.82, 0.82. That would be answer choice B in this case. P-value, this is our p-value, right here. 0.007. Yeah, this should maybe be 0.01, but we can just say it's 0.00. So we'll just say D. Our test statistic, that is right here, negative 2.43, negative 2.43. There we go. And we said that we're rejecting. So we reject. And that's how you do that.